For this fieldwork, you're going to be investigating infiltration. Infiltration is the movement of water downward through the soil under gravity. It's a key flow in the water cycle, and it's also one of the most straightforward to measure, which makes it ideally suited to fieldwork. The rate of infiltration will vary from place to place due to a range of different physical and human factors. In areas where the infiltration rate is high, then the soil moisture store will be more significant, and water will transfer more slowly to the river channel by through-flow, or even percolate into bedrock and then move by groundwater flow into the channel, which is slower still, and therefore will have an overall lower flood risk. One significant factor affecting infiltration rate is soil type. So let's think about soil for a moment. You may never have considered that soil is crucial to understanding the geography of any place. For most of us, soil isn't something we give much thought to, with the majority of us living in urban areas where soil is confined to flower beds. The most we come into contact with it is perhaps on a sports pitch, walking the countryside, or maybe planting vegetables in our garden. Soil might not seem important to us, but it underlies everything. Soil is a product of the rock below it and the weather above it. It's formed over long periods of time, not just by geology and climate, but also by the passage of glaciers, rivers, and even volcanoes have played their part in forming soil. Because soil influences how quickly water can flow into the ground and how much water can be stored, it determines how rivers respond to rainfall and whether or not they're prone to flooding. Soil is also the foundation of our food supply, and the type and health of soil determines what sort of farming is possible and how great the yields are. But soil is fragile, and farming can either enhance or degrade the organic content of soil, which is an important carbon store. So while soil might not seem like an obvious focus for a geographer, without it we're missing a vital piece of the puzzle that we need to understand the geography of any place. And in the coming decades, restoring soil health globally is likely to be one of the most sustainable ways of reducing drought and flood risk, capturing atmospheric carbon, and providing food for a population of 9 billion. Well, the different aspects of soil that I've just highlighted could lead to many different fieldwork investigations linked to all parts of the A-level course. But the investigation that you're going to focus on will be focusing on how infiltration is affected by soil type. You're going to work through the 6 stages of fieldwork in order to investigate how soil type influences infiltration rate. You're going to collect your own data and share it with others, then present it so that you can analyse it and draw some conclusions about whether soil type does indeed seem to influence infiltration rate, before finally evaluating the success of the investigation. When designing fieldwork, we normally choose an appropriate scale of area to carry out our data collection in. Not so large that we can't effectively sample it given the time available, but nor too small that we can't see significant variation. And importantly, an area which is logical for the type of investigation. So for an investigation involving the water cycle, a small-scale drainage basin would generally be an appropriate area. That's not going to be possible for us to model in this investigation, but by collating data with each other, you'll be able to see how infiltration rates vary in different places. And then, having completed the investigation, you'll hopefully have a deeper understanding of one aspect of the water cycle, be more familiar with the different stages of fieldwork and what they look like in practice, and have hopefully started to make some ideas about what you might be interested in investigating for your own fieldwork project.